So let us start with I think NAT is clear to everyone. Network address translation. Is there anyone who wants to have the basic understanding of NAT? Tell me. Basic understanding of NAT, which is your network NAT. Network address translation. Is there anyone who needs the understanding for this topic, NAT? Tell me, anyone? Or should we straight away start with the part?
No, I need to
It is
understand.
convert the
Sorry?
I need to understand.
Okay, you need to understand. Okay. So just try to understand Mini here. Let's suppose this is your ISP. Okay. And this ISP has been connected with your organizational router, which is known as your edge router. Okay. And further, all of these has been connected with your PCs like this. Okay. Let's suppose this is organization ABC. And we have another organization to which again the router has been given connected with the same ISP, and this organization name is your XYZ, let's suppose. Okay. And I have configured IPs 10.1, 10.2, 10.3, 10.4, and 10.5. Similarly, as we know in local area, we can configure the 10 network because it has been reserved. Now, so over the internet, it is something 100.1 and 100.2, 200.1 and 200.2, like this. And with ISP, let's suppose my Google has been connected like this, which is having an IP address 8.8.8.8, something like that. Okay. Is everything till here is clear, Mini? Tell me. Mini?
Yes.
Okay.
Yes,
Now.
yes.
Okay. So tell me, Mini, if this PC 10.2 tries to ping Google, at ICMP request, don't you think it will look like something like that? Source IP would be 10.1, sorry, 10.2, and destination would be 8.8.8.8. Tell me, isn't this ICMP packet look like this while it wants to communicate with the Google? Tell Mini?
Yeah, yeah. Maybe
Yeah,
someone can help too. I don't know.
maybe.
Someone else here can help also to answer.
No, I'm asking you right now. So I'm just
Oh,
asking you. Okay, so I'm just asking, do you think that ICMP requests look like this or not? Tell me. This is your source IP, and this is your destination IP. And destination is your Google, and source IP is something look like this. Similarly, from an organization XYZ, again 10.2, this PC generates an ICMP request. And just look at this ICMP request as well. Now, both the ICMP requests, don't you think looks like same? Of ABC organization and XYZ organization, tell me.
I'm not sure.
Just compare it, you see that the source IP
Yeah, they
on both
look
are same
same.
and the destination IP on both the same are same. So it means that both the PCs are generating the same ICMP request. And
Okay.
when this ICMP request reaches the ISP via their respective networks like this, okay, what will happen? Now, here, because this reaches the Google like this. Now, in this case, the Google will get confused to whom to send the information and whom not to send the reply, because their both test source IPs are same. That's why. So now what will be done? What will Google do? Okay, now sorry, not Google. What we will do? We will configure NAT here. How? Just try to understand. I will say over ISP. This is my Google which has been connected to it. And this is your organizational router like this. And okay, so these are your IPs 100.1, 100.2, 200.1, 200.2, and 200.1, 10.1, and 10.1, 10.2, 10.3, 10.4, 10.2, 10.3, 10.4, and 10.5 like this. So what I will do, I will divide this router into two parts, both the routers like this. Okay, one will be known as my NAT inside, and other will be known as my NAT outside, something like that. Okay, this one will be your NAT outside, and this one will be my NAT inside. Now what will happen? Now what happens? Just try to understand it. If 10.2 tries to ping, to Google NAT, I will tell my router that if any traffic is coming from 10.2, just convert it into 100.3. Why? Because see, over the internet here, I am using the 100 range IP address. That's why whenever I'm gonna convert it, this particular IP, I have to make sure I am converting within the range over the ISP which I'm connected over the internet. Same way in 10.3, I will say if any traffic converts from 10.3, you will have to convert into 10.4. And same here as well, 100.5. Same in the case of XYZ organization as well. And it will be 200 range. Make sure this 200.3, 200.4, 200.5, and 200.6. Now, what will happen? This PC2, let's suppose the PC is having 10.2 as an IP address, it will ping and ICMP request will be generated, something like that. My ICMP request will look like something like that. Okay. So source IP would be 10.2 and destination as 8.8.8 because my Google IP is 8.8.8, something like that. Okay. And this ICMP request, the moment it reaches this particular interface having an IP address 10.1.1, what it will do, it will convert my source IP from 10.2 to, just a second, I think I'm using the same 10. Yeah. What it will do, it will convert my source IP having an IP address 10.2 to 100.3 because I told him to do so. So 100.3 slash, this is your source IP, and this one would be your destination IP 8.8.8 and 8. And it will be sent from this port to ISP and then reaches the Google. something like that. And same thing happens in this case as well. If this PC tries to ping, this one will be your ICMP request with source as 10.2 and destination at 8.8.8. So when it will reach is my inside interface of net, what it's gonna convert, it will just convert it into my ICMP of 200.3 to 8.8.8.8, something like that, and will be sent over the internet to the Google. Now you see, Google will not get confused because it is receiving traffic from two different source IPs. Is it fine to everyone? Tell me.
Yes, sir. Thank you.
Welcome. Anyone else? Anu, AK, Veer, Abdul, you want to ask something?
No, I'm clear, sir.
You're clear? Okay, so now this is NAT, and we have done NAT as well before. Okay, so the thing is, NAT is not resolving the problem for which we have created it. Okay, now, so in order to solve this problem, what we did, we come up with a different solution, which is known as your PAT, 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 which stands for Port Address Translation. Okay, this one. PAT stands for Port Address Translation. What it will do for all private IP addresses, we require only one public IP. And what it will do, it will translate source IP address and source port number. It will translate source IP and source port number when packet hits the inside interface. Now, what does it mean? Now, follow very closely. What will happen? Let's suppose this is your ISP connected with your organization router, which is known as your edge router as well. And this edge router has been connected with the further switch like this and your PCs. 10.1, 10.2, 10.3, and 10.4. 100.1, 100.2. And somewhere here, my Google has been connected with an IP address, which is your 8.8.8.8, something like that. Okay, now what will happen is very simple, just try to understand. What I will do, I will take one public IP for all these private IPs, and that IP would be my 100.1 because I will say whatever the IP is on my interface, which is, let's suppose this is my interface, serial 0 by 0 by 0. So I will say, and this is my GIG. And make sure you have to convert it into two parts. One is your NAT outside and NAT inside, like this. So This one will be my NAT outside. Sorry. This one will be your NAT outside. And this one will be my NAT inside. So whenever a packet having an IP address 10.2, source IP is 10.2, hits the inside interface of NAT inside, what it will do? It will translate that into, it will translate source IP and source port number when packet hits the inside interface. Inside interface means NAT inside interface, like this. So the moment it will hit, what it will do, it will just convert this particular 10.2 into 100.1, and it is coming with the port number 1, because this is the port number 1. This is 2 and this is 3, something like that. Clear or not?
Yeah.
Yeah. This is your port number 1, this is your port number 2, and this is your port number 3, like this. Okay, and it will reach the packet like this. So now be the traffic coming from 10.3, 10.4, 10.2. The source IP, the public IP, only the one public IP I'm gonna use, which is on the interface serial 0 by 0 by 0. And the and we are gonna configure PAT in the same way, the way we did NAT. Same as NAT, we just have to use one keyword. Use one keyword, which is your overload. Overload. This keyword has been used, and rest it will be fine. Rest we don't have to use it. Okay, clear?
Yes.
Okay. So let's do this practical. It's very simple. Okay. So I'll just show you how to do this practical. We'll just wait for a little bit time. Sorry. Now see. Let's take some router. This is your organizational router connected with an ISP router. And further, I'm gonna use my server like this. Okay. Just wait for a second. Okay, just allow me 2 to 3 minutes. Let me configure this, and then I'll start further. Okay. Like this, okay. Just give me a second, guys. So let's configure the routers. First of all, and name this as, so no, enable configuration terminal, interface gigabyte, 0 by 0 by 0, enter. IP address 10.1 space 255.0.0.0, enter. No shut, and then exit. Interface serial 0 by 1 by 0, enter. IP address 100.1 space 255.0.0.0, enter. Clock rate 64,000. No shut, and then exit like this. And give the host name. This is your edge router. Like this. Okay, this is my edge router. Now let's move on to the next one. Which is your CLI. And no, enable conf t interface serial 0 by 1 by 0, enter. IP address 100.0.0.2 space 255.0.0.0, enter. No shut, and then exit like this. And interface gigabyte 0 by 0 by 0, enter. IP address 8.8.8.1, enter. Sorry, 255.0.0.0, enter. Now share, and then exit like this. And make sure to change his host name as host name is your ISP. And do not forget to give the IPs to the end devices as well. So we'll see. So next off. Like this. Okay, is it fine till here, everyone?
Yes.
Okay. So let's first of all give the IPs. What about others?
Yeah, so fine. So
Okay.
Yeah, it's fine.
So now tell me, if I want my network 10 to communicate with network 8, which is your Google server, what I have to do? Tell me.
We have to configure routing protocol like the RIP.
RIP,
yes,
EAGRP, OSPF, and anyone.
yes, yeah, yeah,
Any protocol.
yeah.
Okay. Now, so
Yes.
let's go to router. And yeah. So show IP route, enter. Conf T router, RIP, enter. Network 10, and the network 100. And then exit as well. Now go to another router. Show IP route. Conf T, enter. Router RIP, network 8, enter. 100. Network 100. And then exit like this. So IP route. Okay. So here our IP is running. You all can see. Go here. Let's check. Exactly. So let's check, are they communicating with each other or not? The connection has been established successfully. You see?
Yes.
Okay. Now let's follow the packet how it traces. Now let's suppose it started from here. Okay, it reaches the router. Now it's gonna reach the router. Just see the uh, just see the source IP and destination IP here. Look for layer 2, just see the layer 3 here. Okay. Now, next. Let's check it out when it's going over the network, when it's going over the internet, what it does. Tell me, do you see any changes in the IP address when it goes over the network? Any changes?
No.
Same?
Yes. No. No changes.
Okay, good. Now, let's configure that here. Now, how to configure that? The process is same as the ACL. Awesome. What we have to do is go to router. On T, enter. Interface serial 0 by 1 by 0, enter. IP, NAT, outside, enter, and then exit. Enter. Interface gigabyte 0 by 0 by 0, enter. IP NAT, side. First thing is that what we have to do. The next thing is what we have to do is to configure ACL. Okay, now what I'm gonna do, I'm gonna configure an ACL. Okay. So configure ACL. Access list 10 permit like this. Okay. And ACL has been configured. Clear to everyone?
Yes.
Any doubts still here? Now, what we have to do, just write down IP NAT inside source, create a list, and match that list with interface number. Oh, sorry, access list 10. And then what we have to do, just write down interface GIG, sorry, interface serial, yeah, 0 by 1 by 0. Because I want to take the IP address of serial interface serial 0 by 1 by 0 whenever you are leaving the interface. And just write down the command as overload. This is your keyword. And press exit. That's all you have to do. Okay, now just try to see, are they communicating or not still? Are they still communicating? Now, let's follow the packets. Just see the routing. Okay, source IP is 10.2 and destination IP is 8.8.8.2. Clear? Okay, now let's see when it leaves the interface and it goes over the internet. And tell me, do you see any changes in the IP address? Tell me.
Yes, 100.0.0.1.
Clear?
Source IP here.
Yeah. Have you all understood? Veer, Abdul,
Got it.
Yes, sir.
Mini, Anu.
Yes, sir. Got it, sir.
Okay. So now let's go to any of the router. So let's suppose I have gone to this router. Let's suppose just go to this router and just write down show IP NAT translations. See, these are the port numbers, respective port numbers. On ICMP, when you do the ping, then it will be your respective port numbers. 5. It is a random generated port numbers. Make sure this. Yeah. Any doubts still here to anyone? Okay. So now, so as per our syllabus, we have completed almost everything. Okay. Now in CCNA syllabus, we have covered our network fundamentals, routing, switching, and even miscellaneous topics. And one topic has been left, which is your IPv6. Okay, which we will do tomorrow. And most probably tomorrow will be your last class. Okay. Okay. So if you okay. Standard has been configured. See the number here. Yeah, what I said. See access list 10. Yeah. We will talk about this. Okay. I know. Okay, it is yeah. Okay. So we will talk about this after the class. Okay. Okay, to everything is clear till here or not? Tell me.
Yeah.
Okay. So all the things have been covered. Okay, if you have any doubts, you want to ask something. Okay, so tomorrow will be probably our last class with the IPv4, IPv6. And if you want any doubts, do let me know. We will keep a extra class as well. Okay. If you guys want an extra class, we will keep an extra class as well. Okay.
Yeah, so there will be DNS topic.
We haven't covered the DNS.
I think no, sir.
DNS is very simple. Nothing about DNS. I hope you know. Do you
Yes.
know what is DNS?
Yes, I know, but
Yeah, it is
in the
just
networking.
it is just to, like for example, the way we configure the IP DHCP pool, the same we have to do like this. Like for example, IP DHCP pool, abhi. Let's suppose I've given the network as 10.0.0.0 to 255.0.0.0. Enter default router, just 10.1. Okay, enter and just give DNS server. Any, like for example, you're given 9.9.9.9. Enter and then exit. That's all.
Yeah. Okay.
Then when you go to any PC, you see automatically a DNS server will be allocated to them. Like this. See. You see? The DNS is
Got
coming
it.
automatically. Okay.
Okay.
Same if you will go here, you will find the same thing. Clear?
Yeah.
Okay.
Yeah, and one more,
So
sir. Can we
yeah,
do SDWAN after CCNA?
it's up to you. Yeah, you can do. If you
Yeah.
are enough comfortable with CCNA, everything is clear to you in CCNA,
Yeah.
you can directly go for SD card. Nothing like that.
Okay. Thank you.
Okay.
Yeah.
Okay. Anyone else who's having any questions? Abdul, Mini, Anu. I think we are
I'm
good.
good. I'm
Okay.
good, yeah.
Okay,
All
we are
good,
also
sir. Yeah.
okay. Then let's meet tomorrow. Okay, at the same time. Okay, we'll do the last
Yeah,
topic.
yeah.
We'll do the last
Yeah.
topic IP basis. Okay. Okay.
Yeah, yes, sir. Good night.
Good night. Good night. Bye
Yeah,
bye.
thank you, sir. Good night. Bye.
Welcome. Bye bye.